Okay, today we're going to take a step away from our tiles. What I'm finding out is that people are getting caught up in tiles and the tile mat, but the tiles are just supposed to be a tool. We can solve equations without them. I don't want you to give up the tiles. I just want to show that there is a way to solve this and be thinking about this. We're still talking about how we solve an equation, and then when we're done, we're going to talk about how we know we're right. So we have Lillian wants to solve this equation, and she decided just to simplify each side. So she started with the 3x plus 1 minus x, just wants to simplify that. So when we're simplifying, we're just, remember, putting those like tiles together. So this is a 3x and this is a minus x, and then plus 1. So I can combine these two. If I take 3x and I minus an x or add a negative x, I'm going to get 2x plus 1. So this side is going to simplify to 2x plus 1. Now she's going to simplify the right side. So we simplified the left side, simplify the right side. If I group these tiles together, this is a 3x and a positive x. So I have 4x and then minus 5. That's going to stay. So if I simplify both those separately, combining these two, I get 2x. So I got 1 plus 2x on the left side. Combining these two, I get 4x. So I got 4x minus 5. All right, so we talked about what the word isolate means, because I keep saying isolate the variable. And the kids came up with a lot of great definitions of isolate. Coronavirus, having to be by yourself, getting everything away from the other ones. Those are absolutely true. So the variable is x. I want to isolate them. So I want to get them away from everything else and together all by themselves on one side of the equal sign. So all the steps that we're doing are going towards that. So what's going to be my first step in isolating? I actually already simplified. I already did 0 pairs. So I could do, flipping, taking off balance sets, or adding balance sets. Well, I like to flip first. And flipping, all it really does is it changes this minus sign to a plus negative. Why do we do that? Well, so many kids look at this minus sign and go, does that mean subtraction or negative? It means the same thing. Remember that subtracting is the same as adding the opposite, and opposite means -5, like the opposite of 5 is -5. So it's just easier for us to really see the equation if we just change this to a plus -5, and then there's no questions about what that one is. So we have 1 plus 2x on the left side is equal to 4x plus -5. Now I want to isolate the variables. So what's my next step? Well, I already flipped. So it's either going to be taking off balance sets or adding balance sets. I know when I can take off balance sets when I have the exact same type of tile, same side and everything on both sides. And in this case, I have 2 positive x's on the left side and 4 positive x's on the right side. So I'm going to take off balance sets. I'm going to take off 2 x's, which is going to help me to isolate. It's going to get rid of all the x's on the left side. So, okay, so I took off 2x from both sides. Those went away, so I'm left with 1 on the left side, and I took off 2 x's from the right side, so I have 2x plus -5. Still not quite there. The 2 x's has some -5s with it, so technically I want to make some 0 pairs. Now I know that I have to add balance sets because there's nothing I can take off. And if I add 5, I'm going to make some 0 pairs right there. So I'm going to add 5 to both sides. Okay, so adding 5 to both sides now gets me 2x is equal to 6. I have now isolated the variable. I only have unit tiles on one side and x tiles on the other. But I have 2 of them, and if I know that I have 2 of them, I want to figure out how much one of them is. Well, if there's 2 x's is equal to 6, I can divide both sides by 2, so each x is going to equal 3. What's the solution? What did we just find out? Well, we found out that for this left side to have the same value as the right side, x should equal 3. At least that's the work that we did. So now we're going to check it to see if it's really true. So we got an answer of 3 is equal to x. When x was in the equation, it stood for some random number she was trying to find. We worked backwards and we found that we think it's 3, but now we can check it. So the way to check it is to plug in 3 for wherever we see x in this original equation. So I had 3x, so instead of writing 3x, I'm going to write 3 times 3 plus 1 minus 3, and these both simplify